particular section that is there on the cone. Now if I view it from the top, it will be something like this. That is an ellipse, which is showed by this shaded part which is there. And again, for ellipse, E is smaller than 1. So you can say that for ellipse, if for drawing an ellipse or getting an ellipse, if I pass a plane slightly with a slight angle, and if I cut a cone, then it will result in an ellipse which seems like this. Next is parabola. We know that for parabola, this plane has to be parallel to edges. Now what edge it has to be parallel to? This is the cutting plane, which is depicted by this red line in this 3D figure. This is the slant side of the cone. Now this plane has to be parallel to this side of the cone, that is the slant side. If this is parallel, then my eccentricity will be equal to 1. And if I remove this section, that is O, A dash, A and B, if I remove this, this something of this sort will remain, and if I view it from this side, then this is what I'll view, which is a parabola, that is B2, A2 and B2 dash and A dash. For eccentricity is equal to 1, parabola, and we can say that for getting a parabola, pass a plane parallel to the edge of the cone, that is edge of the cone, that is slant edge of the cone. For an hyperbola, the angle has to be very steep. First for the circle it was parallel, then for say parabola it got a little bit steeper. Sorry, not for the parabola, for ellipse it was like this. I got a circle, then if I made it the plane slight angle, then I got an ellipse. If I made it parallel to the cone, say this is the cone, this is the axis of the cone, if I am passing the plane exactly parallel to it, then I am getting a parabola. And then again, if this is the axis of the cone and I am making a very steep angle with it, then it will result in what is shown in the figure. You can see this is at a very steep angle. This angle is almost tending to 90 degrees, but not 90 degrees. It is almost tending to 90 degrees, and again I have removed this section which is beyond this line, and I'll get something of this sort, which is also depicted in this red thing that is there. Here eccentricity is always greater than 1. That should be kept in mind. Now let's discuss the first part, that is the construction of ellipse. Let's see, there are different methods for construction of ellipse. Arc of circle method, concentric circle method, oblong method, directrix focus method. So we are discussing 4 methods today for construction of an ellipse. For step by step we'll be doing this. Okay, let's start with the first method, that is arc of the circle. Before starting with arc of the circle method, let's know a few things about ellipse first. Now for an ellipse, that is A, C, B and D, we have a few things to know, that is AB, this is the major axis, CD is the minor axis, this is the center of the ellipse, that is the intersection point of the major and minor axis, that is point O. This F and F1 and F2 are the focus of an ellipse. An ellipse has 2 focus. If you see that if there is a mirror which is of this shape, that is this is a concave mirror. Now if I have a concave mirror, if I have 2 concave mirrors, so I have 2 focuses, and if I join both of them, I'll get an ellipse of this sort. So again, for focus, what happens is, if parallel rays of light are incident from this end, just like my cursor is moving, parallel lines are incident here, then they will certainly pass through the focus. So this point is known as the focus, and F1 and F2 both are the foci of the ellipse, that is A, C, B and D. Moving ahead, we have this certain definition of ellipse, that this is the second definition of ellipse. The first 2 methods are based on the second definition of ellipse. Then we have directrix method, which is based on the first definition of ellipse. So let's see, let's observe the figure carefully, and line by line let's interpret what the definition says. So we have these different points on the ellipse that we have taken, and we have drawn lines from one focus and joined those points, and then taken that point and joined to the other focus. Now what this definition says is that if I measure the distance of F1 to P1, add it with distance of P1 to F2, that is the total distance of F1P to P1F, that is F1 P1 plus P1 F2, that will be always equal to F1 P2 plus P2 F2. That will always be equal to the length of the major axis, that is AB. If I take any point on the circle, say I'll take this point as N, and if I I'm sorry, just went away. Yeah, so this is F1 to Pn, then Pn to F2, the total length. Okay, that if I add it up, I'll get it equal to AB, and this will always be equal to P1 F1 P1 and P1 F2. So any point on the circle, any point on the ellipse, if I measure its distance from both the focuses and add those distances, it will be always equal to AB, that is the major axis, and it will always be equal to constant because AB is not changing. Now if I have the major axis, another thing is there that these are the minor axis endpoints. So if I do the same thing with the endpoints of the minor axis also, then I'll get the length of the major axis, that is F1C plus CF2 is always equal to F1D DF2, and which is always equal to the length of the major axis, that is AB. So we can see that F1C and CF2 are equal. So we can say that F1C is equal to CF2 is equal to F2D is equal to DF1 is equal to half of AB, that is OA or OB. Why is this? Because F1C and CF2 is equal to AB. Now if I am saying that these both lines are equal, then I can say that twice of F1C is equal to AB. So what happens is that it becomes CF1 or CF2 or F2D or F1D, all are equal to half of AB, that is half of major axis. So why this definition is very important to us for this? Because say if the length of the major axis and minor axis are given, we can find the focus. Why? Because we know the distance between C and F1 and D and F1 is half of the major axis. So we can cut arcs on F1 and we get the points F1 as well as F2. Other than that, if we have say AB and we have both the focuses, then we can also construct the minor axis. Or if you have the minor axis, the major axis plus the focus, will be able to construct the minor axis. So let's move. First of all, what is the first thing? We know the length of major axis and minor axis. So let us, for arc of the circle method, these two things are given in the question, that the particular length of minor axis is X and say my major axis is Y. So let's start. First we will draw the major axis and name it as AB. The next thing is we will draw the minor axis and name it CD, and the intersection point of AB and CD will be named as O, which is the center of the ellipse. And we also know that A, C, B and D, all these points will be lying on the ellipse. Now what we need to do is we just need to mark a few points around which the ellipse is going to pass. For that, first of all, we will mark what? We will mark the focus. How we are going to mark the focus? Now we will put into definition. What was the definition saying? That the length of the focus, the focus is the length between the distance between the focus and point C or point D is equal to half of the major axis. So I will take my radius equal to half of AB, that is my major axis, put my center at C and cut arcs at here and here, because I have focus on both sides of CD, like this and like this. Now again, to make sure that I am getting an accurate focus, I will do the same procedure. I will take radius as half of AB, put my center as D and cut arc on these arcs and line AB like this and name it as F1. This is my first focus and this is my second focus. Now the next thing that I will do is, now I will divide F1 and O into few parts that are equal parts. So from F1 I will take measurement, that is I will take radius of 3 to 5 mm and I will cut arcs on F1 and O, say 1 2 3 4 till 1 2 3 4, that is 1 2 3 and 4. Take equal distance from F1 and cut these arcs and mark these points. Now what are we going to do next? Now with length equal to A to 1, that is A to 1, I am taking the radius. I am going to put my point at my center point at F1, going to cut an arc above and going to cut an arc below. Then what I am going to do is I am going to measure the distance between 1 and B, and with F2 as center I am going to cut arcs on the arcs which I have come from FV. See, something like these. I have taken radius as A to 1 and then put my center as F and cut this arc, and I have cut this arc. Then I have taken 1 to B, kept center as F2, and cut arcs here and cut arcs here, and mark these intersection points as P1 and P2. So these are another 2 points that I obtained on the circle. Now I repeat the same thing for 2. How I'm going to do that? I'm going to take the radius as A2, put my center as F, cut arc here, then 2 to B will be my radius, F2 will be the center, cut arcs on the arcs and name them P2 and P-2. Now I'm going to do the same thing for 3 again. A to 3 will be my radius, center will be F1, cut arcs above and under. Then 3 to B will be my radius and F2 will be my center, cut arcs above and under on the same arc, like this. So I will get my P3 and P-3. Then I'll do the same thing for 4 again. So I have this P4 and P-4. Now what I'll go do, I'll repeat the same methods that I have done on the left hand side of D, and I'll repeat it on right hand side of CD, that is the minor axis, and I'll do something of this sort and repeat the same procedure. So get P5, P-5, P6, P-6, P7, P-7 and P8 and P-8. Now I have a lot of points on my ellipse. So now what I'm going to do is, in clockwise or anti-clockwise, I'm going to, in order, starting from C, I'm going to start from C, then I'm going to go to P8, P7, P6, P5, then B, then I'll go to P5, P-5, P-6, P-7, P-8, then I'll go to D, then I'll go to P-4, P-3, P-2, P-1, then A, then 1, 2, 3, 4, and then come back to C. When I have connected all these points in this particular order, then I'll get my ellipse C. This is the ellipse that I have got in purple. This is the required ellipse by arc of the circle method. I hope you understood. Otherwise, you go on seeing the video once or twice, ask a professor to confirm and practice it a lot. It's very easy and you'll be able to get it. The next thing that we are going to discuss is concentric circle method, the construction of ellipse by concentric circle method. Now again we are going to know the length of the major and minor axis. What we are going to do is, we are going to construct 2 concentric circles, one of the diameter of major axis, one of the diameter of minor axis, and the center of the circle, both the circles would be point O, that is the intersection point of major and minor axis. So we will suppose that we have the length of major and minor axis, and we will use them to draw the ellipse by this method. So first draw the major axis AB and minor axis CD, as we did in the previous problem, AB, and then we are going to draw CD and mark the intersection point as O. So we have it. Then what is my next step? With center is equal to O and radius is equal to half of AB, that is OA or OB. I'm going to draw a circle. Then what I'm going to do, I'm taking the radius as half of CD and putting my center as O, and I'll draw the circle passing through the minor axis. What I'm taking, first circle passing through both the points of the major axis and then the minor axis. So I have of the circle, let's see, first I am doing it for the major axis. This is the circle that I have drawn. Then this is the minor axis circle. Radius was equal to OA or OB for the major axis, and then with center O I drew this circle. With for minor axis, OC or OB will be my radius, and I have drawn this circle with O as center. Now we are going to divide the circle into 12 pi. I told you in locus also that 12 parts division of a circle should be right on your fingertips. When I say 12 parts, or when your professor says, or when the question says something that is related to division of 12 parts, you should be able to do it in minutes. So this is what you are going to do. You are going to divide the circle into, I'm sorry, we'll have to take it up once again. I beg your pardon for this. I just hit escape instead of hitting the next button, so I'll have to go to the slide once again and then start it. Okay, so we were here, we drew both the circles, yeah, and then we are going to divide the circle into 12 parts like this. First the major circle, and then we are going to, thereafter we are going to divide the minor circle also. Minor circle now. Okay, now we proceed to the next thing, that is I'll just join the line so that I know that I have the pies with me. Okay, now what I'm going to do is, first I'm going to take the points of the outer circle and I'm going to draw vertical lines through them, vertical lines which will be exactly perpendicular to the major axis. Now from the points which are above the major axis, I'll draw lines which are vertically downwards, and from the line which are from the points which are below the major axis, I'm going to draw lines vertically upwards, something of this sort. 2, 3, 4, 5 and 6 are above AB, so I'm going to draw a vertically downwards line like this. Now this 8, 9, 10, 11 and 12 are below AB, so I'm going to draw vertically upwards line. Okay, now we are going to take what? Now we are going to take the center circle, that is a smaller circle of the minor axis. Now what we are going to do, see, the points which are there on the left hand side of the minor axis, that is CD, for that we are going to draw horizontal lines from right to left, and which are there on RHS will draw from left to right. See, don't get confused, this is 2 and 3 and this is 11 and 12. These are on the left hand side of the circle, so we have to draw lines from right to left, right to left, right to left and right to left. And for these which are there on the right hand side of the circle, we will draw left to right, left to right, left to right, left to right. See, and each line will intersect these vertical points and we will mark these vertical points very neatly. The end thing is that these points are the points which are there on the ellipse, and now we see that C, D, A and B are also there on the ellipse, so we need not draw anything extra for that. Now what I'm going to do, I'm again going to start from C and then join these red lines. I'm this in this clockwise manner, and I'm going to get my ellipse. The required ellipse is here by concentric circle method. 2 more methods we are going to discuss. Don't worry, I'm not going to take any break.